Hi, welcome to our math. Today I'm doing a series of videos on solving systems of equations using a matrix. So if I want to use a matrix, I should probably start by creating a matrix. To create a matrix, what I do is I take all of the numbers out of my system and I just kind of list them out. So I have a 5, a -4, a 2, and a 21, a -1, a -5, a 6, and a -24. I have -1, -4, 5, and -21. To make it a matrix, I put square brackets around the numbers, and I've now created a matrix. But what I really want is an augmented matrix. And an augmented matrix is when you represent your equal sign with a line so that you know that this matrix specifically represents a system of equations. Okay, what I want to do is I want to make an identity matrix where every number along the main diagonal are ones. Right now they're 5s. That doesn't really help us, but there's a lot of things we can do to kind of make things work for us. I want a 1 here, and what I'm going to do is I'm going to pivot on this -1, but what I'm going to do is I'm going to say, hey, this first row, I'm going to make it negative row 2. That's going to just switch the orders of my equation, and you can do that. We could have done that up here with our system. We can do it in our matrix as well. Now I'm going to use this -1 to remove the 5. I'm going to say row 1 plus 5 times row 2, because that's a 5, and 5 times -1 is -5. 5 minus 5 is 0. That'll give me a 0 right here. And then for my last row, because I already have a 1 and a -1, I'm just going to say row 3 minus row 2. All right, I'm going to write a lot of this out to make things a little bit easier. I'm going to write out row 1. Row 1 is 5, -4, 2, 21. I'm going to write 5 times row 2, and I do 5 times so that it's, just everything simpler. 5 times row 2 is a -5, a -25, 30, and a -120. When I add these together, I get a 0, a -29, a 32, and a -99. These are really ugly numbers. Don't worry, this process will work, I promise. Then I'm going to have row 3, which is -1, -4, 5, and -21, minus row 2. I put the negative in there because I don't want to end up subtracting. I always want to add down. So negative row 2 is going to become a +1, a +5, a -6, and a +24. When I add down here, I'm going to get 0, 1, -1, and 3. Okay, so I need to put all of this into a single new matrix. So I start with negative row 2. Negative row 2 is going to give me a +1, a +5, a -6, and a +24. This becomes my second row, this 0, -29, 32, and -99, and this becomes my bottom row, 0, 1, -1, 3. Brackets to make it a matrix, line to make it an augmented matrix, and then we have a new matrix that we are going to be playing with. Now, once again, I want a 1, a 1, and a 1, and that is a 1. And it seems to me it would be much simpler to pivot on this 1 and make this row 3, row 2. That will make all of my calculations simpler. If this becomes row 3, then this becomes row 2. Row 2 becomes row 3. So to get rid of that -29, I'm going to have to say row 2 plus 29 times row 3. To get rid of the 5, I have to say row 1 minus 5 times row 3. That will take this 1 and use it kind of as a, eraser, erasing all of the other numbers in this column. Okay, so row 1 is 1, 5, -6, 24, and -5 times row 3 is -5, +5, it's 0, -5, +5, -15, and when I add down, I am going to get a 1, a 0, a -1, and a 9. Okay, next I'm going to do this bit. I'm going to say row 2. Row 2 is 0, negative 29, 32, and negative 99. And then I'm going to have 29 times row 3, which is 0, 29, negative 29, and a positive 87. So when I add down, I get a 0, another 0, I get a 3, and I get a negative 12. If I divide all of this by 3, I get a 0, a 1, and a negative 4. Okay, I'm going to take all of this and rewrite a matrix. I'm going to write it up at the top so that we don't run out of paper space. So I'm going to come up here so you can see what I'm writing, and you'll have to believe me if you're not writing with me. Let's see. My first row was the row 1 minus 5 row 3, which is a 1, 0, negative 1, 9. My second row was row 3, 0, 1, negative 1, 3. And my bottom row is 0, 0, 1, negative 4. Brackets to make a matrix, and a line to make it an augmented matrix. Okay, we are almost there. If you look at this, we are super duper close. All we need to do is take this 1 and use it to zero out these. So we have a row 1 plus row 3. We have a row 2 plus row 3. I don't think we need to write anything outside of these lines. I think everything is going to come together quite nicely, and I think that'll all work. So row 1 plus row 3, that's 1 plus 0, 0 plus 0, negative 1 plus 1, 9 minus 4. Row 2 plus row 3, 0 plus 0, 1 plus 0, negative 1 plus 1, 3 minus 4, and then my last row, 0, 0, 1, negative 4. I have my identity matrix. I have, this translates to x equaling 5, y equaling negative 1, and z equaling negative 4. What I'm going to do next, which I find very important in this kind of situation, is to check my answer. So I have my original matrix here, and I'm going to check each of these. I'm going to say, is 5 times 5 minus 4 times negative 1 plus 2 times negative 4 equal to 21? So let's see, that's 25 plus 4 minus 8, and that should work. Okay, for my next equation I have is negative 5 minus 5 times negative 1 plus 6 times negative 4 really equal to negative 24. Negative 5 plus 5 minus 24. Yep. Okay, then last but definitely not least, we have negative 5 minus 4 times negative 1 plus 5 times negative 4. Does this actually equal a negative 21? That's negative 5 plus 4 minus 20. That works. So we are very happy with our answer. Everything checked out. So we come up here and we write our ordered pair with parentheses, 5, negative 1, negative 4. All right, I hope you enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I will see you on the next video. Thanks.